Alright, objective 3A technically still, and we're still finding graph features algebraically of a quadratic function from standard form. This is still part of standard form, but I broke this up again into two parts. Part 2 is to find the y-intercept and state the domain and range. Now, if you remember from part 1, we found the vertex and axis of symmetry, and you had to follow these 5 steps to find the vertex and then the axis of symmetry. So I'm going to do the same problem. So in this video, you should technically have notes on a page before in your packet based off of how you found the vertex and axis of symmetry. And so I kind of did a short version on the new page in your packet that has the same problem. We're working with the same problem. So you can either build off the notes you had before on the previous page or start brand new and just find the y-intercept. But we're just building skills. And so by now you should have mastered how to find the vertex and the vertex and axis of symmetry. You should be able to tell me, does it open up or down? Does it have a max or min? And now we're going to do the y-intercept. Now, if you see, so y-intercept and domain and range, sorry. If you see x-intercepts as well, we're not going to actually officially find the x-intercepts until Module 3 when we start solving quadratic functions. And so I'm not going to have you list those, but I'm going to, later on in this Module 2, we're going to actually draw them specifically, draw the parabola specifically, and so when you do draw them specifically and very accurately, you will be able to find the x-intercepts, and that'll just be a later expectation. So for now, after we find all the pieces that we're about to find, we're just going to draw a rough sketch of it, alright? So don't worry about the x-intercepts quite yet. But back to the y-intercept and the domain and range. So the y-intercept, please write this down as well, because this is important. We talked about this in the beginning of this module when I introduced quadratic functions again, but the y-intercept, that looks like a terrible one. My board makes me look silly. The y-intercept. If you remember, the x value of the y-intercept is always, always, always 0. Alright, so that means then the y-intercept is as simple as plugging 0 back into my original function up here. Alright? If you notice, to find the vertex, we found the x value, I will switch colors, so we found the x value of the vertex right here, and to find the y value of the vertex, we plugged the x value of the vertex in for my x's of my original function. Now I know the x value of my y-intercept, it's 0. And so to find any y value, if you know an x value, you just plug that x value into the original function and it'll spit out your y value. And so in this case, instead of putting 1 in for my x's like I did in the vertex, I'm going to be putting in 0. So I'll write that step out just so you can see it. I'm going to input 0 in for my x value, or for my x's, in the original function. The original function. So, in order to do that, I will put then y equals 2 times 0 squared minus 4 times 0 minus 3. That'll give me my y value of my y-intercept. Now if you notice, 0 squared is 0, 2 times 0, anything times 0 is 0. So this piece becomes 0, and then negative 4 times 0 also becomes 0. So I'm left with 0 minus 3 equals a negative 3. So my y-intercept hits at 0, negative 3. And if you notice, way back at the beginning we talked about the y-intercept will always be, this is A, this is B, this is C. The y-intercept will always be your C value. In this case, my C value is negative 3. But it makes sense because you do input zeros in for your x's, and that'll spit out the C value. I'm sorry, I put that in the wrong spot. That's the x-intercept, which we don't care about. 0, negative 3. All right, that's the y-intercept. Now, domain. We have to talk about domain and range in this video as well. So if you remember from previous videos, the domain is the horizontal axis, the horizontal x-axis. You read it from left to right. So the question should be, when you're working with domain, it is what is my leftmost point and what is my rightmost point. Now, like I said, I'm going to sketch just a rough draft of this graph, and that should help us find the domain and range, because it's always based off of, and more specifically, the range is always based off of my vertex. Alright, so we don't have to have a very pretty picture, but it should look like a decent parabola. And so I'm going to sketch this before I find the domain and range. We're going to find it based off of the graph itself. So if I plot the vertex 1 down to -5, right here, and then I said that it opens up, so it has a minimum, something like that. That is a decent sketch, all right? Now, if you notice, I didn't hit the x-axis accurately, and so I don't know my x-intercepts, but I mentioned this before. At one point later on in this module, you will learn how to exactly draw parabolas, and so then the expectation will that you will be able to find the x-intercepts as well. But domain, again, the question, and these go on forever, I need to make note of that. Domain, the leftmost point to the rightmost point. Now, it is assumed that this arrow goes up forever, but it also goes to the left forever. And when that's the case, the domain starts, if we read the leftmost point first, it starts at -infinity. And then, same thing over here. It's assumed that this arrow goes up forever, but also to the right forever. So it ends at +infinity. Another way to write this is the symbol all real numbers. You'll see me use that a lot. All real numbers. Now, range is very similar, but range, if you remember from the first video, when we talked about this, range is the y values, or the y-axis, or the vertical movement. And you start with the floor, so the basement. You always start with the floor. Think of a house, you walk on the floor first, and then you go to the ceiling, all right? So my lowest point is right here, all right? And the lowest point I care about, again, because range is y. The biggest mistake with range is you don't know what value to use. This is my vertex, right, this dot. The range is the y values that we care about. So the y value of my vertex, in this case, begins my range. And this is also very important, and this is something you need to know for the test. Because this dot is closed right here, I need to include a bracket saying that my range does indeed include -5. All right, because that dot is closed. So it starts at -5 and it includes -5, and it goes all the way. And if you notice, I already mentioned this, these arrows, they go up forever. So up forever, the same as right forever. Up forever goes all the way to +infinity. Infinity can never be included, so that's why we use a parenthesis around infinities, where we can bracket numbers, because they can be included. Another way you'll see this written is for all y values, -5, so y is greater than or equal to -5 and less than +infinity. This is called inequality notation right here, and this is called interval notation. You'll be able to recognize that no matter what notation you're given. So it makes sense. In this, all y's are from -5 to infinity, and over here, y is greater than or equal to -5, and it's equal to because this dot is closed, and it's less than infinity. Notice it's not less than or equal to infinity because no number can equal infinity. All right, so that is the domain and the range. And I guess I could show you that up here too. For all x's, x is greater than -infinity and less than +infinity. Something similar to that, meaning that all x values exist in this domain, and all y values except for numbers less than -5 exist. All right, so at this point, pause the video and try your problem on your own. All right, you should have already found the vertex axis of symmetry, whether or not it opens up or down, so you can fill in that right now. And so your goal is to find the y-intercept, draw a rough rough sketch of the graph, and then tell me the domain and range. Please pause the video and try that. All right, at this point you should have paused the video and tried your example on your own. I showed the vertex math, but you should have already had this written in a previous video. The vertex is 3, 7. X value of 3, Y value of 7. So that means the axis of symmetry is x equals 3. It opens down. Remember, it opens down because the A term is -1. So negative A term means it opens down, and that means it has a maximum. From that, I could have, and I went ahead and drew a rough sketch of the graph based off the vertex, and I just knew that it opened down, so I drew a frowny face. And then from there, I found the y-intercept. This is technically the new learning right here. And so again, the x value of the y-intercept is 0, so all I did was input 0 into my x's into the original function. And then that spit out -2. So my y-intercept is 0, -2, and so this is actually my bad. We can be a little bit more specific than what I just drew, because I know that my graph hits at 0, -2. So I can at least do that to be a little bit more specific. So I do know that the y-intercept does cross the y-axis at 0, -2. So technically over here, let's check to see if I do that. 0, -3. I did not. If you notice, I drew it at 0 something or other over there. So that's my bad. It goes through 0, -3. Just like that. It's right here for the y-intercept. So let's be more specific than I just did. Let's, when you're sketching your graphs, at least draw it where it crosses the y-axis, the y-intercept, so you do know that piece of information. And then finally, the domain. The domain of a parabola will always be all real numbers. All x's satisfy this. It goes to the left forever and the right forever. So you can write it like this or like this. I don't necessarily care. All I care more about is that if you see either of those, you know what that means. All right. The range is a little bit more specific. In this case, it's flipped because it's going down. The floor at this point goes down forever. Right? Those arrows mean they go down forever. So it starts at -infinity. And it stops then at this ceiling up here. Remember, this is the vertex, 3, 7, and I care about the y value of the vertex. So it stops at 7. And please, you need to be able to, if you're going to write it in this notation, you need to include a bracket, because you have to tell me that you know that the range includes 7 there. And you can write it in any form, integral notation or the other one, but again, I care more about that if you see integral notation, you know what that means. All y's are greater than -infinity, less than or equal to 7. Please check your work with mine. If it looks any different, please check with a neighbor or raise your hand and I will come look at it. But again, please be more specific with your graphs and draw it with the y-axis. Thank you for watching.